Hello, I'm Ege. This is my final project for PHYS-102. I will observe the relationship between the inductance value and external factors such as inductance coefficient value, number of turns, and the thickness of the wire. Inductance is calculated with the formula. Inductance of a toroidal core is calculated with the formula L equals mu0 times n squared times area of the toroidal core over 2 pi r, r which is the radius of the toroidal core. For convenience, we set the inductance coefficient value as mu0 times area of the toroidal core over 2 pi r meter. 3. First, I try to observe the relationship between inductance and the inductance coefficient value of the toroidal cores. To observe this, I use two different toroidal cores with two different inductance coefficient value. This one is called T377 and it has 2.3 nanohenries per turn, and this one is called T388/90 and it has 20 nanohenries per turn. I winded both of them 10 times and then I used sandpaper in order to be able to measure the inductance, and then I attached them to the LRC meter and I measured the inductance from the LRC meter. And secondly, I wanted to try to observe the relationship between number of turns around the toroidal core and the inductance value. To observe this, I use the same toroidal cores. They have 20 nanohenry per turns. Their inductance coefficient value is 20 nanohenry per turn, and I winded this time this toroidal core 10 times and this one 20 times. We expect, as we double the number of turns, we expect inductance to be quadrupled, and as you can see, we were expecting this toroidal core's inductance to be around 8 and it came out as 7.70 something. And lastly, I wanted to observe the relationship between the wire thickness and the inductance value. This one is winded with 0.2 millimeters thickness wire, and this toroidal core is winded with 2.35 millimeter thickness wire. And as you can see, the inductance value was supposed to be around 2, and this also the inductance of this toroidal core was around 2. So as can be seen from the formula, the thickness of the wire does not affect the inductance value. Here is the graph of my results. The graph is inductance value versus inductance coefficient value. You are expecting for the inductance to be directly proportional to the inductance coefficient value, and as you can see from the graph, approximately our inductance coefficient value go up to 7 times higher, and our inductance also went up to 7 times higher. In this graph, we can see the results of changing the number of turns. As can be seen from the formula, we were expecting, when we double the number of turns, we were expecting inductance to be quadrupled, and as you can see from the result, when we increase the number of turns from 10 to 20, our inductance increased approximately from 2000 to 8000. And in this last graph, you can see the results of changing the thickness of the wire. Thickness of the wire does not affect anything about the inductance. We were expecting this, and I used two different wire with different thicknesses, and this is the results of my major